I want to spend a few minutes talking about how it is we start somebody along their trail of becoming a scientist, someone who's focused on the disease of pancreatic cancer. I went through 4 years of medical school, and I decided I wanted to be a surgeon. So I went to 7 years of training for surgery. And when I finished surgery, I knew that I wanted to be a surgeon scientist. I knew that I wanted to dedicate my career to the discovery of new findings in the cure for pancreatic cancer. But really, for this to absolutely happen, there has to be funding. There's just simply not pools of money sitting around to be utilized for junior investigators, and they haven't got much of a track record yet. They haven't really produced a lot of data. It's difficult to fund young people because you're not certain if it's going to be successful or not. So there has to be seed funding available for junior faculty to be able to be successful. And so once that funding is established and they have a solid project, then they have to execute on that project. And ultimately what happens is that more questions get answered, bigger questions get answered, and we drill down to really what we ultimately want to do, and that is to cure the disease. If we think about specifically pancreatic cancer, there are a lot of key questions that we need to focus on. The understanding of pancreatic adenocarcinoma is about 15 years behind that of other malignancies like breast cancer, prostate cancer, gastric cancer. So we need to catch up in a lot of key areas. We need to figure out a lot of new information about actually how does this cancer form. We need to discover a new biomarker for pancreatic cancer, much the same way as what we've done for prostate cancer. We need to have much improved ways to image the pancreas and to find early disease, and certainly need better drugs to be able to deliver to these patients. There really are not any viable therapeutics now for patients with pancreatic cancer. And then ultimately, when you put all things together and you figure out these new targets and develop the drugs, then it goes into clinical trial. So this is a framework as to what some of the questions a junior investigator might want to focus on when they're starting their new career. I started at UCLA in 1997, and I was a junior guy just out of training, really didn't know too much about research. I'd done some in the past, but had identified some important mentors in pancreatic cancer biology. I came up with a scientific question, so I was really focused in the area of angiogenesis and how blood vessel growth affects pancreatic cancer and how we might target that to try to treat patients with this disease. And I identified a mentor in the Department of Medicine, Dr. Robert Streeter, who was a guru in the world of angiogenesis, and he was so generous with his time and really spent a lot of time in mentoring me. And also Dr. Bill Goh and Dr. Enrique Rosengart were really fabulous scientific mentors for me. So these things were all coming together, but of course then I don't have the funding. So as a junior investigator, I put together a project, applied to the Hirshberg Fund, and luckily through that I was given a grant through the Hirshberg Foundation. It was really this seed grant that perpetuated my ability to be able to become a respected and valid and useful contributor to the world of pancreatic cancer biology. So a Hirshberg Grant came, and we executed on a project, and we completed that project and then published that data. And publishing is really the currency of research. It's very important to push that out, and it helps to validate the work. It goes through a peer review process, and we know that it's quality work after it's been published. And what's the results? Well, now our lab has a tremendous amount of funding. Over the last 10 years, we've had several grants from the NIH, and these are listed here. Large center grant, Dr. Goh is the part of. I'm the PI on one of the projects. Another investigator in our lab, or runs our lab, Dr. Guido Eibel, has a significant amount of funding. So through this single seed grant, the preliminary data is established, and then all the additional projects come from there. And in the end, the concept is to be able to bring it back to the patient so that we use the information, we use the data that we get from studying things in the laboratory to bring it back to the bedside to impact patient care. Thank you very much for the opportunity to talk to you today.